my friends. It is time to move into writing algebraic expressions that represent unknown quantities. Okay, so each time that we do one of these videos, we start with a warm-up. So let's write that first. Let's practice. This is called your fair game review. Okay, this is your fair game review. Now, a couple weeks ago, we talked about composite figures. Okay, so a composite figure is a figure that's kind of broken into other shapes, and this allows us to calculate area easier. Okay, so let's say we have a shape like this. I know that I've got 8 units on the top. I've got 14 units on the bottom. I've got 5 units for this length, and I've got 10 units over there. So what our job is to do is to break up the shape into more manageable shapes. Okay, so I think that I will just draw a line right here, and I will do this purple shape. It's a rectangle. And then I'll have this other rectangle right down here. Okay. Remember, you can pause these videos whenever you need to. If I'm going faster, I know what I'm going to write, so sometimes I can go a little faster. Now let's calculate the area of the top rectangle, the area of the bottom rectangle, and then we'll combine those areas. Okay, so let's start with our top rectangle, and it doesn't matter if you start with the top or the bottom. Okay, so this is our shape, and to calculate the area of a rectangle, we do area equals base times height. So rewrite the equation, substitute, simplify. Now, I know that the base of the purple rectangle is the same as the top in here, so these are the base, so it's 8. Okay, and then when I'm looking at the height, I want to know what this length is here. But I don't have it. But I notice that this length here is 10, and I know that 5 of it's already spoken for, which would leave 5 for the height of that first rectangle. So now I can substitute. So remember, rewrite the equation, substitute, simplify. So I can do area equals 8 times 5, simplify 40, and then since I don't have any units, we'll use generic units squared, okay? And that's going to be the area of this first rectangle. Some people like to put the 40 inside there, or even highlight that. Wasn't quite dry. Now let's look at the bottom rectangle, the green one. All right. Okay. So again, area equals base times height. And you could have, remember, you could have split your rectangles up lots of different ways. Okay. So the base, the bottom, is 14. And the height is done, it's equal to 5. Okay, so now we rewrite the equation. Now let's substitute and simplify. So area equals 14 times 5. Area equals, we'll see, 10 times 5 is 50, and 4 times 5 is 20, so we have 70 units squared, so we can put 70 in there. Okay, just a quick, there we go. So we know that total area, okay, is going to be equal to these two pieces added together. So we have 40 plus 70. So we know that area equals 110 square units. Awesome, awesome. All right. So that is your fair game review from a couple weeks ago. Now let's go ahead and write down our learning target for today. Now, our learning target today is we can, okay, I'm going to try to move my camera just a little bit so it's easier for you to see. So we can write algebraic expressions, okay, that represent unknown quantities that doesn't look like a T. There you go. With one or two operations. Okay, and if we want to just really quickly remember what an algebraic expression is, algebraic expression because that's kind of an important word there. Algebraic expression is a math sentence that includes numbers, symbols, but what really makes it an algebraic expression is the variables, okay? It's the variables that make it an algebraic expression instead of a numeric expression. So let me give you a little bit of an example of what you're going to be doing, okay? So let's say, and so here's your example of what we are going to accomplish today. I'm going to give you a math phrase, something like the sum of a number and 8, okay? And we're going to break this down and say, well, what exactly does that mean? So we say, well, let's see, I need to box my key action words. So sum of, okay, tells me that I'm going to be adding. And then it says a number, that's the unknown quantity, right? And 8. So the sum of a number and 8. Now, when it says a sum of a number and it's unknown and 8, you can make up your own variable, and sometimes it'll give you that variable. So we know that this means the sum of, so I'm adding a number and 8. So how about x plus 8? Okay, now this is called your phrase, and this is called your expression. Okay, and this is the work that we're going to do today. First thing that I want you to do is we are going to kind of make a list. So for the rest of the sheet here, if you don't have a lot, you can move to a different sheet. But we're going to make a bit of a table. So down the center or so, draw a line, okay? And what we're going to do is write down some words like sum of, like the sum, words that mean operations. Operations are add, subtract, multiply, and divide. So if I wanted to write operations for addition, okay, I'm going to put those here. I'm going to put things like added 2, because that means to add. Okay. Another thing that I might write is plus, because the sum of a number and 8 is the same as a number x plus 8, or a number x added to 8. Okay, we might say sum of more than, and you're going to want to have this list, right? More than, increased by, okay, total of, and one of my favorites is and. Okay, now I want you to go ahead and draw a line now across here. And we are going to call these ones your addition, okay? So these are your addition operation words. Okay. Over here, let's do some subtraction. So you could say something like you had added 2, you could say subtract from. Just like you have plus, you could have minus. Sum of, if you're subtracting, you could say difference of. more than, you could say less than. You could also say, instead of increased by, you could say decreased by. Okay. Total of, when you're subtracting, you could say fewer than. And another one that a lot of people like to use is take away. So 6 take away a number x. Okay. And these are going to be your subtraction action words, okay? Your subtraction operation words, okay? For multiplication and division, we actually have just a few less, so that's why I don't have as much space down here. But you could say multiplied by. You could say times. You could say the product of. The product of a number and 7. You could say twice. This one you'll hear a lot, twice. This means to multiply by 2. So twice a number x would be 2 times x. Another word that means to multiply is of. Okay? It means of. So this is multiplication. These are your multiplication operation words. Okay, so we have plus, minus, we have addition, subtraction, multiplication. Now let's do division. So division, you could use words like, instead of multiplied by, you could say divided by. Okay. You could say the quotient of. Remember, quotient means answer to a division problem. You could even say groups of. Okay. If I have 10 people broken into x groups, it would be 10 divided by x. Okay. So this is division. Okay. You'll want to have this handy because these are the words that we're going to look for to try to say, hey, if these key action words show up in my learning or in whatever I'm doing, then I know that they mean add, subtract, multiply, or divide. Okay, so let's go ahead and keep that handy. Okay. Now what I'm going to do is I'm going to give you some phrases, and we are going to write the phrases as algebra expressions. Okay, so we are going to practice writing phrases as algebraic expressions. Okay, so I'm going to start with one. And we're going to do this with one operations and sometimes when there's two. So let's start with something that has one operation. How about the difference of a number and 3? Okay. One thing I really want you to do is I want you to do a couple things. Okay, I want you to box the operation word, okay, and then put a circle the numbers. Okay, so difference of, I'm going to put a box around it because it is a key action word. It's an operation word. It tells us that we're going to be subtracting the difference of a number. Okay, we don't know what number, and since we say a number, it means a variable, and 3. So the difference of a number and 3 means this number subtract 3. So we could say something like n minus 3. The difference of a number n and 3. Okay, let's try another one. the sum of a number and 8. Okay, so we're going to do the same thing, the sum of, so I'm going to put a box around that because that tells me I'm going to add a number. I don't know what number, so I can pick any variable, so I could use like r and 8. So I know that I'm going to be adding some number that I don't know and 8. So let's go with r plus 8. And I'm just making up the variables because it doesn't tell me. Now sometimes it does. So you might see something like a number x increased by 4. A number x increased by 4. Well, increased by is my key action where it tells me that I'm going to add. And then my numbers are x and 4. So a number x plus 4. Okay, hopefully you're getting the hang of this. What about the quotient of a number and 3? The quotient of. So I'm put a box around quotient, even quotient of, because that tells me I'm dividing a number. I don't know which number, so I get to make up my own, and 3. So I'm dividing a number n, or whatever number I want, divided by 3, since I said n. Okay, let's try with 2 operations, okay? So what if I had something like, these are going to have 2 operations, so I'm going to write smaller. The product of a number x and 3 minus 7. So the product of a number x and 3 minus 7. Now this is where it gets tricky because I have product of and I have minus, that's another key action, we need the box, okay? So product comes before subtraction, so remember that. The product of a number x and 3, then minus 7. So since product of a number x and 3, we're going to say 3 times x, and I always like to write that as 3x, okay? Minus 7 looks like that. The product of a number x and 3, 3x, the variable always goes after this coefficient here. You could have also written this as 3 times x minus 7 or x times 3 minus 7 because multiplication will always come first. Okay, let's try twice. How about 6 more? Then twice a number p. 6 more than twice a number p. So I have 6, I have more than, and I also have twice. I have 6 more than twice a number p. But remember twice also is kind of like a number because it says we're going to multiply this number by 2. So we're going to have 6 more than twice a number p. 6 more than twice a number p. So we're going to have 2 times p plus 6. And let me tell you why it's more than. Because I'm doing 6 more than whatever this is. Okay? So when you see more than or less than, it means it goes last. I always say more than, last than. Okay? And it's really then, but that's okay. So whenever you see more than instead of just more, or less than instead of just less, you put it at the end. Let me show you one more example. 7 less than 10. Okay? 7, if I have less than 10, I'm subtracting. But I want 7 less than 10, which means less than starts with 10. So I'm actually going to do 10 minus 7, not 7 minus 10. So in this case, we have to write it backwards. All right? Okay. One last thing that you have to be able to do, okay, is evaluate, okay, expressions. So we're going to write expressions and evaluate. So we are going to write each phrase as an expression, okay, an algebraic expression, and then evaluate when x equals 5 and y equals 20. Okay, so I'm going to give you an expression. I'm going to give you a phrase. We're going to write it as an expression, and then we are going to evaluate it using substitution. Okay, we just learned how to do that. So here's our first one. 4 more than a number x. So I have 4 more than a number x. So I have more than, which means I'm adding, and it's only one operation. And I have 4 more than a number x. So 4 more than x. Now, since it's more than, it's going to go last. X plus 4. With addition, it doesn't matter which order we go in because we still get the answer because we have the commutative property of addition. So we are going to do x plus 4 when x equals, and I'm going to look up here and say x has to be 5. Okay, and I got that from up here. I have x equals 5 and y equals 20. So when I write an expression, if I know what the variable is, I can just substitute it in. So rewrite the expression, okay, substitute, and sometimes you can put that in as parentheses like that, and then simplify. So my final answer was 9. Okay, we're only going to do 3 of these. The second one is 3 less than the quotient of 3 less than the quotient of, oops, y and 4. 3 less than the quotient of y and 4. So I have less than, and then I have quotient. Now since quotient means the answer to a division problem, we're actually going to write this part first. So I have 3 less than the quotient of y and a number 4. Plus 3 less than means to put it last. So the quotient of y and 4 would be y over 4 and then minus 3. So this is 3 less than the quotient of y and 4. And I know that y equals 20. Okay, so I would put 20 over 4 minus 3 for substitution. That's 5 minus 3, which is 2. Okay, last one. 6 more than the product of 8 and a number x. So 6 more than means it's going to go at the end. More than, that word than means go at the end. The product of means to multiply. So we've got multiplication, we've got addition. 8 and a number x. So 6 more than, so I know that's going at the end. The product of 8 and a number x, which means 8 times x. So I have 8 times x plus 6. And I know that x equals 5 because of up there. So now I'm going to substitute that in. 8 times 5 plus 6, which is 40, plus 6, which is 45.